Good afternoon, everyone. I literally have a friend of mine who told me that she couldn't attend today because she'd be hungover, so I appreciate your commitment. So welcome to the talk. I've got quite a bit of material, so I'm going to dive right in. Welcome to the talk about AI, when AI is not an assistant. In full disclosure, I'm going to be telling you about the sort of key concepts from a book I published, so there's a tiny sales pitch at the very last slide. But really what I'm here to do is try and get you guys to come around to a certain way of thinking that has only been enabled recently. So when most people think about AI, especially from a sci-fi sense, they think of it as an assistant. And that's no giant surprise, right? Most of the cool cinemagenic things we see in sci-fi are assistive. If you're a fan of the Marvel Cinematic Universe, you'll remember Tony Stark flying around with Jarvis in this beautiful HUD that shows how Jarvis is always available to make a call or give you a Wikipedia article about a Ferris wheel, whatever you need. But it's certainly playing the role of an assistant. Tony's attention is on something, and the assistant is helping him with it. But I'm here to tell you that there is a different way to think about AI, and even design for AI, that does not need that framework. So can anyone tell me what this is? It's a DSLR, right? To take a picture with this, you turn it on, you set the mode. If you're like me and you don't want to use the LCD screen, save your battery, you hold it up to your eye, and there's a little piece of AI in that frame that'll tell you, is the light right? Is it too bright? Is it going to be peaked? Can you see the person? Right? Is it level? That helps you take the picture and click the picture, look at the LCD screen, and say, oh, I like this picture, or I don't, and I'm going to return back to the task. Now let's compare it with this object. I won't ask you what it is because almost universally people think it's a tile. It's not a tile, though it looks like a tile. Apparently, tile is the way that we're going to design all of our AIs in the future. This is a device out of Sweden. It's a life blogging camera. And the way it works is it stays plugged into your computer overnight charging. Then from the moment you unplug it, as long as that lens sees light, it takes a picture every 20 to 30 seconds, constantly. Then at the end of the day, when you plug it back in, 4 really cool things happen. The first is that all the photos that you've amassed over the course of your day, depending on what your settings are and how long you've had it unplugged, that can be between 3,000 and 5,000 images, and it uploads them to the cloud. The second thing that it does is it uses some smart algorithms in order to break your day, by photos, up into scenes. Here's when you were at the comedy club, here's when you were hungover, here's when you missed Chris's talk. The third thing it does is it uses another algorithm to find the best photo from each scene, based on your preferences and your prior image selections. So it could be, oh, I like sort of tilted pictures or blurry pictures, or more commonly, I like clear faces and horizontal lines. And the last thing it does is it takes those photos and sends them to you and says, what would you like me to do with these? Could be that you say, oh my God, I really shouldn't have had the camera on at that moment. Let's delete that scene. It could be that you say, oh, I disagree with that photo you picked. Let me thumb through all of them and pick the one I really like. It could be that you want to caption it, or it could be just like, those look great, send them up to social media. Ostensibly, these two are the same thing. They're both cameras, and they both have AI. But in use, they're entirely different, right? The Get Narrative camera gets you photos without your having to take photos. That's pretty interesting. Can anyone tell me what this object is? It's a Dyson vacuum cleaner. This one doesn't have AI, so forgive me for this. But let's compare it very briefly with this object. It's a Roomba, thank you. A little bit of interactivity at the beginning since we're all either just eaten or hungry. Right? And these two objects are ostensibly the same thing. They're both vacuum cleaners. But the one on the left is a tool for you to vacuum. You pull it out of wherever you store it, you plug it in. You press on one switch with your foot in order to turn it on, press on a second switch to release its lock, and then the vacuum runs and you can push it around, clean your own floor. The thing on the right sits in a cradle charging, much like the Get Narrative camera, until a specified time and date. Then it leaves that cradle, goes all around your floor, vacuuming up, and generally it will try and make its way back to the charging cradle. and wait for the next time it needs to go. Now, I have a Roomba. His name is Rusty. And he only needs to bother me in 2 cases. One is when he gets lost. 3 now, actually. One is when he gets lost and he can't find his way back to the cradle. The second is when his dustbin is full. He'll beep at me and say, you need to come and do this work. And the third is when he gets stuck. My kitchen cabinets are just the wrong height that he'll sometimes get stuck underneath it. Right? So the thing on the left is a tool for you to vacuum, and the thing on the right is a device, an AI, that gets you vacuumed floors. And that's different. All right, last object. Can anyone tell me what that is? It's a Tesla Model 3, right? It's a self-driving car, but with a very particular stance towards what it means to be a self-driving car. There is still a steering wheel. There is still a dashboard. The seats are still facing forward, right? This is a tool, mostly for you to get from point A to point B. Occasionally, you can let your hands off, but it's still an assistant. It's still set up so that you can grab that wheel if you need to at any time. Contrast this with this one. This is the Google self-driving car. There is no steering wheel in the Google self-driving car. Currently, the seats face forward, but that's because there's only 2. There's probably some good psychological reasons for it, but there's no need for it. In fact, the safer direction is to have your back in the direction of travel, right? Similar to the 2 other examples, the one on the left is a tool for you to move yourself to point A to point B, and the thing on the right is an AI that gets you there by itself. So 6 years ago now, I was tasked with the design of a robo-investor, which is a piece of software that you give some money to. You say each month, here's how much I'm going to give, and here are my financial goals, and then you manage the rest. And I was like, wow, this is a really interesting problem, right? It's not a tool. That's what I'm used to designing for the couple of decades of my career. It's something that I tell it what I want to have happen, and it just does it. And so I said, well, I've never designed anything like this before. I'm going to go research somebody who's smarter than me and has written a book about this. Couldn't find that book. So I wrote that book. And at the same time, I was doing a lot of user research travel and had bought a cat feeder for my cat and had a Roomba for my floor. And I realized that these were all sort of part of the same thing, right? These were a new category of AI. And specifically, they were one that did their work when my attention was elsewhere. So since I grant them agency, and as users, we grant these AIs agency to do work on our behalf, I needed to come up with a name for this category of things, so I call it agentive technology. It's stuff that does its work on a user's behalf. Now, when I first presented these ideas, sort of semi-publicly, to some friends at a local university, those students there were like, well, that's cute, but they're all first-world problems. Who cares if your floors aren't clean? Who cares if you actually have to grab a steering wheel? I said, you know what, you're right. Those are easy to understand examples, but they're not as compelling. So I went out and I searched for some others, and sure enough, I found them. In the upper left-hand corner of the screen, you'll see something called ShotSpotter. It's a service based out of California, but what they will do is they sprinkle a neighborhood with microphones that are connected to the net, have very precise clocks on them. And when they hear a shotgun, when they hear the sound of a shot, they report when they heard it and their GPS location back to the server. And they can triangulate with that data to within a meter of where the shot was fired. Now, it depends on how ShotSpotter is instantiated, but in the deepest integrations with a precinct, they can actually identify the police officers who are nearest and send them a map in real time, reducing the response rate such that on one incident, some cops in the north were driving around, police officers, sorry, it's more respectful, were driving around, and they were worried that they weren't going to get there in time to get evidence because it was snowing. But the response rate of ShotSpotter was so fast that by the time they got there, they found the bullet casings because the holes were still in the snow and the steam was still coming out of them. It's an amazing piece of agentive technologies. In the upper right hand is kite string. Kite string is very low tech on purpose, but it's a chaperone service. So if you're going on a first date, rather than telling one of your friends, you can actually, well, you can, in addition to telling your friends, you can tell KiteString, hey, here's a time, here's a person's name, here's a message, here's a phone number. Then at that time, KiteString will send you a message and says, hey, everything okay? And if you don't respond, it sends the message that you specified to the person at the phone number that you specified. Could be an email address if I remember right. You can also set up a fake safe word. So it says, you okay? And you reply, baseball. It says, oh, wow, you're in distress, and it still sends the same message. But if you respond with your real safe word, say duck, then it just deletes all that information off of the server and lets you continue on with your night. In the lower left-hand corner is Turtle. It looks like a Roomba because it's designed by some of the people who made the Roomba, but instead of vacuuming floors, this helps weed gardens. It has that little green thread that you can see in the image down there, spins around and thwacks weeds right sort of near the base, and goes around. As long as the garden is well tended to begin with, it can help a single farmer cover much more territory. In the lower right-hand corner, you have a picture called Scarecrow, a service called Scarecrow. This is a drone that is trained to hover above endangered herds, and it tracks the people approaching those herds. And if it recognizes those as park rangers, it continues about its job. But if it doesn't recognize those people, it flies down, and that sort of wasp-like noise of the drone scares the herd in a safe direction. In full disclosure, I made that last one up. But the way I made that last one up is what's important. I thought of a problem that I saw in the world, right? We're losing species at an alarming rate. And I simply tried to apply the principles that I had identified in other examples to this problem and came up with that. Then I presented at Delft last year, and some students raised their hand and they said, yeah, that exists. And in fact, that's the thing. The AV drone is created in the Netherlands and is being utilized to keep herds safe. So I was just ahead of my time. But really, those examples are just to show you that this technology is as big as you can think. It's not just constrained to first world problems. It's constrained to any domain where you still need the AI in service of a human, but that work does not necessarily need to be done by that human. If you're a long-time student of artificial intelligence, you'll think, wait a minute, well, why isn't this automation? And my answer is that automation seeks to remove the human from a system, right? In an automation, which is an engineering task, a human is involved only as a quality check, only as a fail-safe. And ideally, that human would not be involved. Contrast with the Roomba or the self-driving car, right? Humans are at the center of the notion of agentive technology. So that's interesting. Let me tell you 5 reasons why I think it's really interesting. The first is that it's new. You'll see some quotes around the word new, and that's deliberate, because the object in the back of this slide is an autopilot. Anyone want to take a guess of when autopilots were first demonstrated in the United States? 16th century? No. Oh, 62. Do I hear another bid? 1914, at the Chicago World's Fair. Now, that piece of technology was in a high-stakes domain. It took tons of engineering time, lots of money, and electromechanics in order to make that happen. That was not something that a citizen of the day could think up and make happen. But today, we live in a world where the APIs exist and the infrastructure exists in people's pockets that you and I can begin to code an agentive solution this afternoon. That's why it's new. Of the 36 examples I have in my book, almost all of them are from the past 6 years, because we are at a point now where it's new and you and I can do it. And that's pretty cool. So number 1. Number 2. If you studied interaction design formally, and I'm not presuming that you have, but the model that we had when we did study it was that of a hammer. It's a tool to get things done. And when you think about the design of a hammer, you think about things like affordances. How do I, as a carpenter, know where to put my hand? You think about the system state. Well, what am I looking at to know that my task is done? It's the nail. Right? And that's the combination of constraints and affordances and system states is largely the thing that we have been talking about for decades, since World War II, and this industry, this field of study was really begun. And that's kind of inappropriate when we talk about agentive tech, right? The Roomba doesn't have a handle. I don't need to think about its affordances for my doing the work. I need to communicate my goals to it. And then I need some tools in order to correct it if it goes off the rails, metaphorically speaking. Right? A better model for that is a butler or a service, right? Where the butler knows who I am, what my preferences are, but after that point, he tries to stay out of the way until such time as I have a new request or he has a problem. That's an interesting model. Diving more into the domain, less metaphor and more practicality, this is the model that most interaction design talks about. It is a useful oversimplification of what happens between a human and a computer, right? Human sees the state of something. They think, oh, wait, that's not in the final state that I want. And they look around their interface or listen to their interface, and they compose a plan of action and then execute that action and say, OK, this, I think, will get me closer to that state that I want. It's called the see, think, do loop. And if you're just looking at the human side of things, it's a circle. But I don't look just at the human side of things. And so the blue line at the bottom is the opposite side, the mirror reflection of computer side of it. And because computers grew up differently than humans, they have different names for the same things. For a computer, we call it input, processing, and output, but it's the same thing. And together, when you connect them, they form this little figure 8 that sort of describes over and over again what's happening inside of a typical interactive system. And that system is that model is fundamentally broken when we take a look at the agentive types of products. Here is a model of all the unique use cases that agentive technology introduces. I see lots of phones. At this URL, you will get a pixel-perfect version of that same diagram. I call it the bow tie diagram. And I'm going back to it, because now that I've given you the URL, I want to talk about it. Oh, no. There we go. All right, all of these are the unique use cases that belong to this kind of technology. They involve setup. They involve letting the user know what this thing can do, since in ordinary use, you won't see it being used. It involves a sort of a lengthier setup and even like a test run. Can I trust it with my money? Dare I trust it with my child if I'm sending him or her to school in a self-driving car? It involves seeing what's happening in the system even when you're away from it. How do I know that this cat feeder is going to feed my cat and not starve her while I'm away at user research? Right? I want some confirmation that it's doing its thing. I may want to see recent results or how close it was to thresholds. All of that is under C. And then, of course, there's lots of notifications that are involved, tuning tools when I think it's got it wrong, or when my goals change slightly or my preferences change slightly. All those are interfaces for describing your goals and your preferences and then backing away from the thing. Agents typically are let run ad nauseum, like just keep doing it until you hear otherwise. So there's even a phase on disengagement. If you have money in an investment account and you pass away, something has to be done with that money, right? You don't want it to just live with your investment banker or your investment broker. You want it to go to a next of kin or a charitable donation. So there's a disengagement that we have to account for with persistent agents. But since all of these are unique, you can see, like writ large, that yes, we have to have different models, new models, for how to handle agentive AI. One of the things that we try and do in user experience is maximize users' value for the minimum amount of work. That can be visual work, cognitive work, memory work, physical work. During the dot-com boom, we used to talk a whole lot about minimizing clicks. We don't talk about that anymore. But it was an example of minimizing the amount of work and maximizing the amount of value. And in the case of an agentive piece of technology, you set it up once, and then it just keeps providing value. And I can't think of any better ratio of the value that is provided to users versus the amount of work that they have to do. Pine and Gilmore published a book called The Experience Economy way back in 2012, I think. 12? Yeah, I think it was 12. Where they were talking about different types of products that can be offered to market. They use coffee, so I'll use it as well. But they said that a commodity is something that's really cheap and readily available, but it asks you as the user to do a lot of work. If you want a cup of coffee and you're buying from a commodity market, you have to like bring a bag with you, go to their warehouse on the outside of town, scoop up the coffee from a barrel, put it in the bag, worry about storage, worry about grinding, worry about making and cleaning up that coffee yourself. But for that, you'll pay pennies. Contrast that with a product. A product, from a conceptual stance, is some entrepreneur saying, you know what? I will do that work for you. I will store it. I will grind it. I will package it and get it in a store near you. And for that convenience, you pay a premium compared to a commodity. An enterprising person somewhere along the way said, don't even worry about that stuff. You come into my little store that's located even closer to you, and you just tell me what you want. I'll go back, get it for you, bring it to you, and I'll even clean up those dishes afterwards. And for that service, you will pay a premium compared to a product. Now, Pine and Gilmore were building this pyramid specifically because they were trying to figure out Starbucks. How on earth is it that they convinced us to pay $5 for a cup of coffee? And their rationale was because we were providing an experience, right? It's not just a diner. Starbucks ostensibly is a place where you go where they have really cool interior decorations, they have nifty music, they abuse the Italian language on the menu. It's an experience. And for that, you'll pay a premium as compared to a commodity or a product or a service. I raise this up because in a piece of agentive technology, right, the value that it provides is not constrained by the user's attention. All of those, a commodity, a product, a service, an experience, are struggling to find time in the user's day when their attention will allow them to change value for money. But the space where an agent can do its business and still provide its value is nearly infinite in comparison, and that's of interest to businesses. The fourth reason, checking my time, is that agentive is a threshold technology. P.W. Singer wrote a book where he was unfortunately talking about war, but there was one non-war thing that you can pull from it. And he introduced the notion of threshold technologies, which is a technology that once a culture has adopted it, it is loath to return to the old way of doing things. It sounds super first world problem, but I do find the notion of dragging out a vacuum cleaner sort of boring now. But more so, right, if I'm commuting every day with my son to his daycare, right now my attention is not on my son. It is on the road and the other cars and my fury at traffic. Now, if I imagine that I am commuting by bus or a self-driving car, suddenly I have the opportunity to spend time with my kid. Let's read a book. Let's do a puzzle. Let's look out the window. I will be loath to go back to the old way of doing things once I have an agent doing that work for me. And what that means is that there is a first mover advantage for the companies that choose their markets or their product strategy in this direction. All right. The last reason why I'm super excited about agentive tech in general is that it's solidly AI. Now, if you know me from a prior life, you know that I have a lot to say about interfaces in science fiction. So I'm not talking about the general AI that is found in science fiction, like with BB-8. I mean, that's not true. I do think a lot about it. I have a whole blog dedicated to it. But this is not what that's about. I'm here to talk about the AI that we have in the world today. Full disclosure, I work at IBM, so I'm going to talk about Watson, right? I mentioned at the very beginning of the section that AI is new, or agentive tech is new, because we can all do it. And it's not some scary robot thing in the future. IBM publishes 15 APIs that you and I can get on and design today on the internet. And at small scale, it's free. So you can play around and make whatever agents you want just to see if it works, see if you like it, see if it's a viable product. And that's pretty amazing. One of the best pieces of feedback I've got after publishing the book and giving these presentations is that designers especially tell me, I'm no longer afraid of AI. I think I know how to design for it. That keeps me coming up on stage. All right. The last thing I want to talk about in this talk before we move to the Q&A is sort of situating agentive tech amongst other kinds of technology. Partially because I introduce these concepts through products, and it kind of seems like, oh, well, then he's talking about a kind of product. That's not exactly true. I talk about products partially because they're easy to understand. But if we take a look at the set of things that artificial intelligence can do for humans and overlap that with the set of things that humans can do for themselves, it doesn't align perfectly. If the computer can do it 100% confidently, and humans don't need to be involved, we call that automatic. If we're going to do it ourselves, without any assistance or AI involved whatsoever, we're going to call that a manual task. And we have decades of design experience to apply to that. But in the middle, where there's a centaur-like cooperation or collaboration between those two entities, we can break it down into two parts. If the human is doing more work, but getting some guidance or support from an AI, that AI is acting like an assistant, helping you do the task. But if the AI is doing more of the work, and the human is only occasionally looking in, checking in, helping with problems or defining what the goal statement is, that's agentive. Now, when you take a look at this diagram, yes, it's true. Some things can simply go into a single category. The Dyson vacuum is just a manual tool. I can never pull it out of my vacuum and say, I've got guests coming in 5 minutes, just knock out the downstairs and I'll be back. Though, hey, Dyson, if you're listening, that's a business opportunity. And the Roomba really has no other mode than agentive. It does not come with a big handle that will let me stick it into the top of the Roomba and push it around if I just want the exercise or the active meditation, right? It's strictly a product that lives in one category. Or one of my favorite examples is called the garden defense owl, which I incorrectly categorize as agentive in the book, so let me correct that if you're one of my readers. It's automatic. What it does is it lives in a garden and uses a motion sensor to turn the head of the owl towards the motion and then hoot. Scaring off rodents is the idea. And it's automatic. There's no human in that loop other than, oh, you get the benefit of a rodent-free garden. And it's true, I use these tools in order to explain these concepts because they're easy to get. They're familiar, they're first world. But when we look at real products, more complicated products, they exist along that spectrum. Think about text entry on a mobile phone. How you use it determines how you would categorize it. Do you keep your eyes strictly on the keys that you're typing or that you're swiping along? Do you keep your eyes just on the text that is appearing as a result of your interaction, right? Then it's pretty much a manual tool. You are manually entering words, numbers. However, it will correct your spelling. It will say, hey, wait a minute. Oh, no, sorry. It will complete words for you. In my phone, at least, if I type A-G-E-N-T-I, it says, do you mean agentive? And in that case, it's acting as an assistant, helping me finish the word that it's pretty confident that I'm about to type. But it'll also, if I'm just going super fast swiping around, if I misspell something, it'll act like an agent and just underline it and say, I think this is misspelled. Be aware of that. Come back later if you want to fix it. Now, there's no real automatic mode, but perhaps you can imagine ways that that might work. But I bring this one up as an example of more complicated products. I think that sophisticated products, and certainly more as we, as designers and product managers in the world, incorporate AI into the things we build, are going to act more like this, where depending on the needs of the user and the prompts of the AI, we will slide into one of these categories, one of these modes of interaction. And that's a little bit different, right? That's the sophomore lesson rather than the freshman, oh, it's a product. So in the future, people and products and services are going to be floating between these modes as the needs of the user and the AI and the circumstance dictate. And that's going to be new. Because for the past 3 decades, 4 decades, 5 decades, depending on how you count, we've been getting good at helping people do things. Right? Our field began in World War II when pilots were crashing airplanes and nobody knew the reason why. But the British government and the US government studied it and they found out, oh, we're making our planes so complicated that even well-trained pilots can no longer fly these things. And thus was begun human factors engineering, which eventually became user experience once it got to sort of consumer-level products. And even when we talk about assistive technology, assistant AIs, all the lessons that we've had will apply to it. It's just we've got some new tools to help you do the thing you want to do. But in the world with agentive technology, that's no longer the case. We're no longer doing. We're going to be managing robots and softwares that are doing things for us. And in that regard, we're not going to be task doers. We're going to be task managers, right? We're all going to be getting a promotion. So if you sort of like these ideas and you want to learn more, I have published a book, as I said, under Rosenfeld Media called Designing Agentive Technology, AI That Works for People. It's there at that URL, and I tweet pretty incessantly at Agentive Tech and Chris Noessel. As I mentioned, I'm with IBM, and if you want to get in contact with me directly, there's my email address there. Thank you all for your attention. Okay, we zoomed through the presentation so that I could maximize the amount of QA time, or you guys could maximize the amount of lunch time you had. If you're just dying for blood sugar, please head out the door. But if you have a question for me, please step up to the microphone, speak into it, so that the cameras can capture your question. Anyone have something for me? A challenge? A poem?
Hi, Chris. Thank you for a nice talk, really, really nice thoughts. So I've been thinking a little bit in that space as well. I use a similar framework to think about those things. Mm-hmm. Where, if you think I'm on the first level about the manual and the assistant model is more like a master-tool relationship between the person and the technology. Mm-hmm. Then you have the second model, like a collaborative, like a master collaborator. That is pretty much more like what you call agentive way, mm-hmm. where the master, the manager set up the goals, and the
apprentice.
Yeah.
Yep.
Yeah, go ahead.
Goes off and does it. Yep.
Yeah, and the collaborator has some freedom to execute with some understanding of how to execute.
Yep.
And then the third one is will be evolution that I don't have many examples. Will be the peer-to-peer level, where the technology also has own goals, the human has own goals, and they collaborate or cooperate to achieve things together. But in a more there are things the machine you just not do because they have their own goals and their own priorities.
Right.
Have thought about that kind of level because it's not a pure automation. It's still collaboration, but in a more peer-to-peer level.
I have done some thinking about that. Specifically, I just published an article about 2 weeks ago called Robot Keggers and Roomba Spies. Partially because my fear about the notion of a retailed AI is that it enables the retailer to embed their own self-interest in the code in very nefarious ways. I can't imagine some non-nefarious uses, right? A government agent, not in the sense of, dun, 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 but a government agent with whom we might chat about the services that we need from the government, our taxes, our voting, would have its own goals. Make sure that you get to the right place, try and encourage you to vote. I have not written about that. It's a very likely scenario for the future, but I don't cover it here. Okay. The only thing I did cover in that blog post was 4 ways that we might be able to correct the nefarious self-interest inside of an agent. But it's a good model to bring up because this doesn't cover it.
Okay, thank you.
Have you imagined examples where where that dotted line is kind of blurry maybe there's an experience that includes both agentive and assistive, and the user may be kind of, going in and out of various states. I mean, the pilot experience is kind of like that, where it's all automatic, and then sometimes they just really got to take over. They're being assisted as they're taking over. But to what extent have you thought about what may exist along that boundary?
Yes, I have. So in two ways, particularly in the book, and in one way that's not in the book, certainly there are, because agentive tech is currently bounded by narrow intelligence, it will necessarily encounter situations that it is ill-equipped for. Some of those it will know it's ill-equipped for, and some of those it won't. But in those cases where it knows it's ill-equipped for it, it has to hand the problem back to the human. That's called the handoff problem in classical sort of AI studies. And I talk about it particularly in terms of agents here, that there are certain ways that we hand that off so that the user becomes suddenly informed, that they feel like they've got field awareness and can indicate that they are confident that they can take it over. I also talk about alternate ways of handling the problem, such as handing it off to a remote operator who's trained at that. So that's one answer to the question. A second answer to the question is that throughout the book, I propose a speculative service called Mr. McGregor, which is going to help somebody garden, a persona garden, but I stuck to agentive models. There are lots of assistive ideas around it, but I'm saving that for a follow-up book that's about assistive. The third thing is just that the examples in the world, or particularly from academia, from computer-supported cooperative work, is a field of study that has really deeply gone into the handoff problem. The other side is also called the take-back problem. One anecdote from history that I adore and that will be vital for us to remember moving forward is that GE started working with automation back in the 1950s. One of the big problems that they encountered was that if workers had worked on the line in the factories for years and years and years, once they added robots to the factory floor and asked the people to step back and manage it, they had a whole lot of experience and patterns in their brain about when things are going wrong and how to course correct, how to get the factory floor back on track. And for that first generation of worker who had a lot of experience, it was a manageable problem, and in fact, they saw some gains. Once those people retired and they suddenly had people who had no floor experience but were simply asked to come in and manage a bunch of robots, it turns out that they didn't have the experience to know when things were going wrong, so they waited for alerts. They didn't have the experience to know how to get things back on problem, so they learned on the job. And the net gains became net losses. In the second generation, it was unworkable. The lesson that I pull from this is that we have to manage the design of our things to enable people to build that experience, to apprentice to other humans before we give them the job of managers in high-stakes domains, where either the risk is to a great deal of money or to human life or suffering. In small domains, like a vacuum cleaner, who cares? But in the larger domains, we have to think about that as agents and robots as being part of a team rather than as being replacements for humans. Good and important question that we have to keep into our practice. Any other questions? Comments? Awesome. Enjoy your lunch. Enjoy the rest of the conference. Thank you all.